Okay, chapter 6, section 3. So have your books there. And I want to do a little reviewing. And I'm going to ask for hands. If you can tell me what's one fact about a parallelogram, I'd like to see a hand so everybody's not talking at once. Evelyn? Opposite sides are congruent. Andrew? Opposite angles are congruent. Consecutive angles are... Consecutive angles are, anybody? Supplementary. Consecutive angles are supplementary. Jesse? If it has one right angle, all the angles are right angles. Diagonals bisect each other. Evelyn? I thought we were going to miss the very first one. The opposite sides are parallel in a parallelogram. I think that's it, right? All those things? Ah, we had one more. Very good, Maxwell. If we have one diagonal in a parallelogram, they form two congruent triangles. What we are going to do today is do the converse of what you just told me. We started with, if I have a parallelogram, we know all those facts to be true. So if I know one of those facts to be true, what do you think our conclusion would be? We have a parallelogram. So we get to figure out if we have parallelograms or not. So let's look at it right over here. Conditions of a parallelogram, which are ways you can prove a quadrilateral, four-sided polygon, is a parallelogram. If both pairs of opposite sides of a quadrilateral are congruent. So I need to have both pairs congruent, not just one pair. Then I know it must be a parallelogram. Here's the abbreviation for it. If both pairs of opposite sides are congruent, then quadrilateral is a parallelogram. Next one. If both pairs, and notice this both pairs stuff, of opposite angles are congruent, then that quadrilateral is going to be a parallelogram. The next one. If the diagonals, what are the diagonals supposed to do? Bisect each other, then that quadrilateral is a parallelogram. Now, all three of these, even though they didn't say both down here, we have to have both diagonals in order to have them bisect each other. We had both pairs of opposite sides congruent, we had both pairs of opposite angles congruent, we had both diagonals bisecting each other, and then this next one says, or if you have one pair of opposite sides that are both parallel and congruent. So if I want to just use one pair of opposite things, I have to know two things about it, instead of having two pairs of opposite sides and knowing one thing about it. Maybe that can help you remember. So if I have one pair of opposite sides, I have to know two things. They need to be congruent to each other, and they need to be parallel to each other, and then that's enough to say, hey, I have a parallelogram. So armed with those four facts, determine whether the quadrilateral is a parallelogram, and then we are going to justify our answer. So looking at this over here, do we know that is a parallelogram? And then if so, why? Let's start with your first statement. What good does it do me to know that these things are supplementary? True. Thought your hand was up. What does that tell me? It tells me something important, that those consecutive angles are supplementary. Parallel lines. That's it. I know that these are parallel because my consecutive interior angles are supplementary. That means these lines are parallel. There's fact number one that I need. What's my next thing, Evelyn? Oh, I was pointing at the right thing, but what else do I know? Anybody? They're congruent. They're both 14. They're both 14. Therefore, is that a parallelogram? What reason? There are four of them. You can look in your book if you need to. The last one, which said one pair of opposite sides, both parallel and congruent. It's a parallelogram. That's how we know we have a parallelogram. It's that last one. It's that fourth one. How about 1A down here? Do we have a parallelogram? I agree. Why? Both pairs of opposite sides are congruent. That would be your reason. How about 1B? Do we have a parallelogram? No? Yes? I don't know. Well, I've heard no and I've heard yes. Somebody defend your position. All right, Evelyn, you're ready to defend your position. Oh, have you changed your mind? Okay. Elizabeth? So, you ready to say we have a parallelogram? Andrew, you said no. You want to defend it, or are you going to pass it off to your neighbor to defend it? I agree, it's not. It's not one of those things. What's the issue here? I don't have both pairs. I have one pair of sides congruent, but it takes both pairs, but not the other one. I have one pair of opposite angles congruent, but not the other one. So I don't have enough? No, we cannot prove that this one is a parallelogram. So, use parallelograms and a little bit of algebra. So they give us some values out here. F to k, 3x minus 1. So 3x minus 1, that little piece. Kg, 4y plus 3. 4y plus 3. JK, 6y minus 2. 6y minus 2. And KH, 2x plus 3. KH, 2x plus 3. Find x and y so that the quadrilateral would be a parallelogram. What factor are we using of those four? Diagonals bisect each other. That's exactly right. So I know that 3x minus 1. Subtract 2x would be x. If I added 1, I get how much? And I know that 6y minus 2 equals 4y plus 3. So if I subtract 4y, I have 2y. If I add 2, I have 5. Y is 2.5, 5 over 2. Find x and y so that the quadrilateral is a parallelogram. So how about my 7x? Must equal 56, so what is x? 4y plus 4. What do I know about it? Subtract my 4y, I have 1y. Add my 26. Yeah. So over here, tell me about 3x plus 4. So I'm going to subtract my 3x and 2x, add my 2, which would make it 6. X is 3. And I know my 4y minus 9 equals 2y plus 5. Subtract my 2y, so that's 2y. 2y. Add my 9. 14. Y is, yeah. Concept summary. The review. Show that both pairs, opposite sides parallel. That's the definition. That's what a parallelogram is. We didn't go over that as one of our four, but that's the very beginning definition. Show that both pairs, opposite sides congruent. Show that both pairs, opposite angles congruent. Show that diagonals bisect each other, or one pair, and I wish they would have used the word one instead of a pair, but just to remind you, one pair, opposite sides, both parallel and congruent. The only time I can only use one pair of anything is if they're sides and I know two things about them, that they are both parallel and congruent. Now we're going to do a little coordinate geometry, and I've left this one here so you can see it. Graph quadrilateral KLMN, and they give us the vertices. So here's the graph of all these vertices in this quadrilateral. Determine whether the quadrilateral is a parallelogram and justify your answer using the slope formula. What do slopes tell us about a figure or about lines? They tell us what? Whether they are parallel or not. How do I know if two lines are parallel with their slopes? They're equal, if their slopes are equal. So what they did, slope KL, in order to get this slope, they used the slope formula. What is that slope formula again? There we go. There's our slope formula. They took the second y minus the first y over the second x minus the first x, and they got a 1/6. And when they did the opposite side, they got a 1/6. I know these are parallel. And then they took the side kn. They did this one right over here, and they got a 6. And they took lm, and they got a 6. Those sides are equal slopes. They are parallel to each other. So why do I know it's a parallelogram? Both pairs of opposite sides are parallel by the definition of the parallelogram. Both pairs of opposite sides parallel. Write a coordinate proof. Let's try this out. If one pair of opposite sides of a quadrilateral is both parallel and it's congruent, then we are going to prove that it must be a parallelogram. I know it's one of those things, but we are going to do it with what's called a coordinate proof. A coordinate proof takes a figure on a coordinate plane, and we are going to label the vertices. What point is this? We draw it in a special position. We want one corner to be at the origin, 0, 0. Then, I don't have any idea the ordered pair that goes here as far as the numbers. So we just pick two variables. I'm going to pick A and B. That's the point over A up B. Now we are going to be given that we have parallel and congruent one side. So we know, I'm going to pick these opposite sides, congruent and parallel. So I can use that fact when I go to do the rest of my vertices. Let's pick this point right here. You know one of the values, either the x or the y. Which value do you know? It's not the x, there's a hint. What is the y variable? 0. We know it is 0 because it's sitting right here on the x-axis. I don't know how far I have gone over, however. So I'm going to have to pick a new letter. C. I've used A and B already. I just go down my alphabet and now I'm over to C. Now I want you to see if you can figure out the coordinates of this point. And we know what to write in terms of what is already written. See if you can figure out what the x or the y is. One of them's a little easier than the other. What's y? B. I know y is B because they have told us that we have a parallel side. So this and this is parallel, so this is going to say exactly the same distance away from this line. So if it used to be B away, it's still going to be B away. So I know it's B. Can you figure out the x one? And you can. What is it? That's correct. I know that this distance is C. Well, this distance is also C because they told us we had congruent sides as well. So if that distance is C and this little distance right here is A, I have gone A plus C in order to get over there. So that last corner point, I know the values in terms of the A, B, and C. I don't know any numbers yet. Now we are supposed to show that we have a parallelogram. Well, I'm going to do the same thing we did earlier. I am going to figure out the slopes of each of these lines. I'm going to call this line 1, that line 2, that line 3, that line 4. So why don't we start by figuring out what is the slope of line 1? How will I get the slope of a line? y2 minus y1. What's the second y? Minus over. So I get 0 divided by c, which equals 0. Now I'm going to figure out the slope of line 3 up here. Actually, we already know that, don't we? Slope of line 3 up here, but actually we don't know the slope, but we know it's going to be parallel. So what do I have? B minus B, those are my y's, over A plus C minus A. Well, B minus B is 0. A's would cancel. C, 0 divided by C is 0. So what do I know? Those are parallel. 2 and 4. Let's try that. Slope of line 2. So same formula. Y sub 2 minus y sub 1. So I have B minus 0 over A minus 0. I'm taking y sub 2 minus y sub 1, x sub 2 minus x sub 1. B minus 0 is B. A minus 0 is A. There's the slope for line 2. How about the slope for line 3? I'm going to take y sub 2 minus y sub 1, b minus 0, x sub 2, x sub 1, a plus c minus c. What's my numerator? B. How about down here? A. C minus c, those all cancel out. Do they have the same slopes? We've got a parallelogram. Both pairs of opposite sides are parallel to each other. We know, yes, we do have a parallelogram by doing that. You'll get to do a problem similar to that. Let's go to your books. Page, what are we, 417? Number 1. Determine whether each quadrilateral is a parallelogram and justify your answer. Number 1. Yes. What reason? Both pairs of opposite angles congruent. Number 2. No. How do you know? No. The diagonals do not bisect each other. How do you know that? Because we have a 5.1 and a 4.9, that diagonal has not been bisected. Number 3, kites. Remember back in elementary school for some science class, I don't even remember what grade it was, but we had to build kites. And I thought, oh, it'd be so cool to build a box kite. So I built a box kite like that. Any of you ever flown a box kite? All right. They're kind of cool. Charmin is building the kite shown below. She wants to be sure that the string around her frame forms a parallelogram before she secures the material to it. How can she use the measures of the wooden portion of the frame? And so you can kind of see where they have the wood portion of the frame and where it is string. The light black lines are the string and the heavier brown lines are the wood. How can she use the wood portions of the frame to prove that the string forms a parallelogram? Explain your reasoning. And they show you a little top view over there to the right. And that's where you want to look, is that top view on the right. Yes. If it's going to be a parallelogram, what would she need to know to be true? Yeah. So if those little sticks are going to bisect each other, I know A, help me out with the letters. AP? What do I know about AP? There you go. And DP? Is it BP or PB? PB. So we have Adrian Peterson, personal computers, or maybe it's political correct, and Dr. Pepper and peanut butter, and I don't know. So what would that do to us? Thank you. I appreciate the compliment. What would that do to us now that we have written this out? What are we trying to do? We're trying to show that this quadrilateral is a parallelogram, that our kite's a parallelogram. So you wrote this out. I mean, I like it. We have all these food items, or whatever. But then what? I mean, so what if those things are true? You just need to finish your statement. Diagonals bisect, so it is a parallelogram. They wanted us to explain, and so if I am going to have those things equal to each other, that makes the diagonals bisect, which means we must have a parallelogram. Number 4, find x and y so that the quadrilateral is a parallelogram. So let's start out with 8x minus 8. What about it? Is it 6x plus 14? It is. Subtract 6x gives me 2x. Add the 8 gives us 22, divide by our 2, 11. X is 11. Boy, this is easy stuff, isn't it? 6y plus 16, what about that? So if I subtracted 6y, I'd get a y. Subtract my 2. Number 5. Again, we want to make sure we have a parallelogram, so I know 2x plus 3 is left hanging, equals what? Equals x plus 7. So if I subtract my x, I get 1x, subtract my 3, 4. Y's, what do I have? 3y minus 5. Equals y plus 11. So I'm going to subtract y, which gives me 2y, add my 5, gives me 16, y equals 8. See? And we no longer have our peanut butter because we ate it. Oh, it's even getting better. Next page. Number 6. Graph each quadrilateral. Before you get too distracted with my awesome jokes, graph each quadrilateral. Number 6, we're on page 418. Graph each quadrilateral with the given vertices, determine whether the figure is a parallelogram, and justify your answer with the method indicated. So we're going to be using different ways of trying to determine whether this forms a parallelogram. A is negative 2, 4. B is 5, 4. C is 8, negative 1. D, negative 1, negative 1. Now these things are supposed to look like parallelograms, does it? Or maybe it doesn't, I don't know. Does it? Ooh, that sure doesn't look like a parallelogram. We are supposed to use the slope formula method. Well, I'm real suspicious that a couple of these lines are not parallel to each other. Which ones would you guess? AD and BC don't look too good. So why don't we pick those first? The slope of AD If we are going to show that we have a parallelogram, opposite sides have to be parallel, which would be the same slopes. So using our formula, tell me the numbers. Slope A to D. -1 minus 4, y sub 2 minus y sub 1 over, I'm going to write minus a -2, and then we'll simplify. So -1 minus 4 more is -5 over -1 plus 2. 1. -5 over 1 is the number -5. So there's our slope for AD. Slope for BC. Hey, that's clever too. There's a good joke waiting to happen. Are you guys faster than me, Mr. Lorenz? You got that one already? He doesn't want to admit it. He's just shaking his head and looking away. AD, BC, that's a good history thing. Oh, see? All right. What are we doing? BC, tell me the numbers. Negative. All right, let's get back to the geometry. Y sub 2. Y sub 2, -1 minus 4, over 8 minus 5. You're going to miss these jokes over break. -1 minus 4. Tyler won't. What's -5 over 3. Well, that doesn't reduce, so what do I know here? Not parallel. Not a parallelogram. Opposite sides not parallel. Number 7. But the good thing, see, this is being recorded so you can listen to these good jokes again. Number 7. I don't know. It wasn't worth repeating. Number 7, we're graphing again. -5, 4 is W. X is 3, 4. Seems like I hear a lot of mumbling. I'm sure it's talking about the geometry. And if not, that's a little object lesson. Y, 1, -3. Z, -7, -3. When you draw this one, what do you think it's going to be? A parallelogram or not? That's the question. Sure looks like it, doesn't it? By the way, on that last one, I mean, we're pretty sure that's not a parallelogram, so why did we need to do any work? Prove it. You have to prove it. You can't just say, look at it, it doesn't look right. Can't do it. You've got to prove it. Same thing down here. I bet it's going to be a parallelogram, but we've got to prove it. So if I am going to prove it using, they tell us a certain method. What do they say? Midpoint formula. What in the world is the midpoint formula going to do for me? The what? The diagonals bisecting each other. That's what we're dealing with here. The only time I'm going to be dealing with a midpoint is if I have bisecting things. And so if I have the midpoint of this diagonal being the same as the midpoint of the other diagonal, then they must bisect each other because they have the same midpoint. That's how we'll use this method. So if I am going to get the midpoint of WZ, how do I find a midpoint? Do you remember the midpoint formula? The root thing is the distance formula. I'm still looking for it. Add them and divide by 2. I'm going to take the x's and add them and divide by 2. Negative 5 plus 1, and we'll divide by 2. This is our midpoint formula. We'll take the y's, 4 plus a negative 3, which would be 4 minus 3, and we'll divide by 2. And we will get the midpoint for the y, for the wy. I said the wrong letter up here, didn't I? wy, midpoint. Let's see, negative 5 plus 1, that's negative 4 over 2. 4 minus 3 is 1 over 2. That reduces to negative 2, comma 1/2. There's the midpoint of the diagonal wy. So let's try the diagonal zx and figure out the midpoint for that one. So take our x's, negative 7 plus 3, divide by 2, negative 3 plus 4, divide by 2, negative 7 plus 3, negative 4 over 2, negative 3 plus 4 is 1 over 2. What does this one simplify to? Negative 2, comma 1/2. Are they the same midpoints? Yes. So we have a parallelogram by what reason? Diagonals bisect each other. The reason we have it is because diagonals of our quad bisect each other. Number 8. Write a coordinate proof for the statement. So we know we're going to draw a picture here. And if we're going to do a coordinate proof, we want a coordinate system. Now we will, wrong thing. We will label our own values on this coordinate system, so it doesn't have to be on graph paper. You could do it on graph paper if you wanted. Writing a coordinate proof for the statement. If a quadrilateral is a parallelogram, then its diagonals will bisect each other. So draw a parallelogram like I did in my earlier example where one vertex is right here at the origin. So if you want to take out your parallelogram picture, your parallelogram pencil, that might make it easiest, I don't know. That was a joke too, but anyway. Draw a parallelogram with a vertex out. It wasn't a real good one either, like some of the others have been this morning. Draw a parallelogram, a vertex right at the origin. And then we want to figure out coordinates. And I'm going to do this one a little bit differently, just so that you're comfortable doing your own coordinates. Now that bottom left corner is what? 0, 0. It is 0, 0. It's at the origin. Now I'm going to go over here to this bottom right one. Tell me the ordered pair that would make sense for this bottom right one. A comma 0. It's some distance to the right. I don't know what it is, so I just use the first letter of the alphabet, but I do know it's up 0. Now let's come to the top left one. What would I say for that top left one? Over B, because I don't know how far. Up C, I don't know how far. So I have to just pick new letters. It's not A that I'm over or up. And then that top right one. B plus A, comma, C. B plus A, comma, C. B plus A, comma, C. And you could call it A plus B. That would work too. Now they wanted us to use what method? The what? Diagonals bisect each other, which means what are we going to need to figure out? They would have the same midpoint. So we're really doing what we did on that last one, but this time we don't have numbers, because who needs numbers in math? Again, we are trying to figure out, when I do these two diagonals, do I get the same midpoint? So maybe for ease of showing what we're doing, I'm going to call that diagonal 1, and I'm going to call this diagonal 2. So we are going to find the midpoint of diagonal 1. That looks like slope when I just say M, doesn't it? Midpoint 1. Numbers is 8. 8. All right, so if I'm going to find the midpoint of this diagonal 1, I'm going to add my x's, 0 plus b plus a divided by 2. And we'll add our y's, 0 plus c, and we'll divide by 2. And then we'll simplify whatever we can. What's 0 plus b plus a? B plus a divided by 2. Over, comma, what's the y? C divided by 2. That's all we can do with it. That is the midpoint of that first diagonal. Midpoint of our second diagonal. So I am going to take my x's and add them. B plus a. My x's are b and a. B plus a divided by 2. My y's, c plus 0 divided by 2. So let's simplify this one. B plus a divided by 2. Can't do anything with that. Comma. C divided by 2. That's the midpoint of the second one. Are those midpoints the same thing? There we go. So, same midpoint. Then diagonals bisect each other, making a parallelogram. That's coordinate proof in geometry. So now you're old pros at coordinate proof in geometry. Or at least you're started. Page 417, 1 through 28.